Okay, in this video we go over another type of control chart, and it's when we have data that is not continuous, but it's really just we have either rejects or no rejects. So we look at something and it's either good or it's bad, and we're going to focus on a proportion chart or a p-chart. This is our data, and the scenario of this is that we're working for the United States Post Office or UPS or FedEx, and we're processing packages or mail. And what we want to do is make sure that the address is correct, and that it's being shipped to the correct address. So what we did is that we every day, so think of these as daily samples, we grabbed 100 packages that had already been sorted. So every day we grabbed 100, and then we counted out of that 100 if that package was good or not. So each package was either good or not. So out of the 100, 3 of them were bad. So our proportion defective, or proportion, we'll just call it P, is this divided by this. So that is what I want to plot. The name of the chart is what you're plotting, so I want to be able to build a p-chart, something that looks like that. But again, it's a control chart, so we have to put our control limits on it. So what are the control limit numbers? First of all, we need to calculate our average proportion defective, or P bar. It's equal to the average of all of these. Then we have to calculate our standard deviation of P. You don't have to do this, but I'm going to go ahead and format that cell as a subscript, so it looks a little bit like that. The formula for that is the square root of P bar times 1 minus P bar. This is formulas out of the book. That's the numerator. Divide by my average area of opportunity. So since it's 100 every time, I'm going to divide by 100. So just make a note, this 100, it's not always 100. It's actually, you know what? I'm going to go ahead and just grab this one, but it is 100 for this problem. It may not be for future problems. And that's the sample standard, or excuse me, the standard deviation of the proportion. And I don't probably need to show these. Let's just show 2 or 3 decimals. Show 3. Okay. Now we need to decide how many number of standard deviations do we want to, and let's use 3. 3 is the most common. You can occasionally use something between 2 and 3. And then I'm going to calculate my upper control limit, my lower control limit. The upper is equal to the average plus 3 times my standard deviations. And then my lower is this minus 3 times my standard deviations. Now I got a negative number. Well, a negative number is not possible. A proportion defective, we will never ever get a number here less than 0. You can't get a negative proportion. So let's lower bound this by wrapping it in a function, a max function, where we'll take the max of that number we just got, but if it turns to be 0, or if it's negative, then we want to at least make it 0. So look what I did. I took the function, the original function, and I wrapped it or nested it within a max function, and it's the max of this term and 0. Okay, so these are my upper control limit, my lower control limit. Just going to point to it, put some dollar signs around it because I'm going to copy it down. Now I can plot my p-chart. There's my proportion effective. Hold the control key down, click somewhere in the middle of a cell on, and then build that. And that is a process that is also not, that is in control. We don't have any point that went outside. It can never go negative in this case. It could go positive, but there's no point outside the control limit, so we would say this process is in control. It is in control. Thanks.